right, hello once again. This is Jeff Scott of Rankin Technical College, and I've been going over the PowerPoint presentations and writing some code for Murock's Android Programming 2nd edition by Joel Murock. This is the textbook that's part of the AWD1112 1112 Java programming class. And we're up to Chapter 4. And Chapter 4, as you can see here, come on, is on how to test and debug an Android application. I believe that the majority of this chapter, we're not going to be writing code. We're going to just be looking at a few things. All right, so the author mentions at the beginning of the chapter here that as you develop Android applications, you need to test to make sure that they're performing as expected. If there are problems, you'll need to debug your app to correct any problems, and the chapter shows how to do that. So, as we look, here are our applied objectives and our knowledge objectives. Our applied objectives: to be able to test and debug Android apps, trace the execution of an Android app with logging or with toasts, use Android Studio to set breakpoints, step through code, inspect variables and inspect the stack trace, add emulators for devices that use old versions of Android or that have large screens. Those are our 4 applied objectives. Our knowledge objectives on this page or slide in the next: distinguish between testing and debugging, distinguish between syntax errors, runtime errors, and logic errors, list 2 ways to trace code execution without using a debugger and describe the difference between the two, describe how method chaining works and describe 2 of its advantages, explain what a stack trace is and how to use one when you are debugging, and explain why emulators are often necessary to test and debug an app. So those are our 4 applied objectives and our 6 knowledge objectives. So, as it says, the goal of testing is to find all errors or bugs in an app. Now, tell you this quickly, and you may have heard me or someone say this before, but supposedly at least this is the truth. One of the first people, the first real programmers, who really did a lot, was someone whose name is Grace Hopper. And Grace was a rear admiral in the U.S. Navy, and she was very involved in the COBOL, or Common Business Oriented Language, programming language. And rumor has it that one day, back when they were still writing, I believe, machine language, that Ms. Hopper had written a program that she was just sure that it was correct. But for some reason, when she ran it, it kept giving incorrect results, and she couldn't figure out why. Eventually, it led her to remove the back of the computer, which at that time was using the big cathode ray tubes that almost look like the old type of TV tubes that you used to see. And what she found when she removed 1 or more of the tubes was literally a moth that was in the back of the computer. So that became the first computer bug. So removing that bug was the first act of debugging. So where the goal of testing is to find all errors or bugs in an app, the goal of debugging is to fix all those bugs that you find while you're testing. Now, the author mentions here a 4-step phase for testing your app. In the first phase, you check to make sure the interface works as it's supposed to. So they give you an example here that if your app is supposed to work in both portrait and landscape orientation, that it does so. You want to check it on different screen sizes. You want to check it that it runs in any kind of platform. So, you want to test the app basically to make sure the interface works as expected. And if you've got buttons on there, that the buttons all work like they're supposed to. That if it has a text box or text boxes, that they take information like they're supposed to, etc. So that's step 1, checking the interface. Step 2, that this is validating that the program works as expected. So when you give it valid data, then it does what it's supposed to do. All right. In the third step, now you want to give it invalid data. You want to try to break your program. And it sounds kind of funny. You think, well, why would you ever want to break your program? Well, the idea is much better you break it than somebody else being able to break it. You don't ever want to take a program and put it out to production and find that your end users break it. You'd rather break it yourself so you can fix it. Finally, you want to test it on all target devices. Ideally, that means you want to test it on an Android phone or phones, on an Android tablet or tablets, and on an emulator. So, they show here, and this is the slide from page 99 in the book. This is an example of the graphical editor that's displayed by Android 4.2.1 API 16. All right. And as they mentioned there, that there are several different things that are in here that you can actually choose. Now, I wasn't going to bring up anything here, but I guess I will anyway. So let's see if we can bring up the tip calculator that we were working on previously and look at a couple things in the graphical editor. And I hope to be able to finish this chapter in just one lecture. Believe me, we've got other chapters coming up that are going to take many lectures to go over. All right, so if I go back, my app, my resources, and I bring up layout, I bring this up. Remember, this is what my app currently looks like, and we can look at it either in design mode or we can look at it in text mode. We've looked at this before. There it is. So the author is saying that you can come in here and you can set a lot of different things. All right. There are ways, notice it says 30% here, but I can make this bigger. So if I want to check out something, or I can make it smaller if I want to check out something. There are different things in here that I can check, and I don't remember what all of them are. All right, as it says pan and zoom. So there's a lot of different things that you can work with in here. All right, so you can zoom in and out like I just showed you. You can view it on a different screen size. So right now it's running on an Ch04, but if I wanted to see what it would look like in something else, I can do that. I can change the orientation. There is a go to next state button on here someplace. And I don't remember where it is. I can change the theme. Okay, notice that it's automatically picked the right API for me. I guess that's it for the theme. So now it's in landscape. Now it's back to portrait. Okay. You can also change platforms. So there's a way to do that in here. I'm not going to run through that right now. Again, there's different themes that we can use. There's a lot of different things. You are supposed to be able to put your mouse over this and get a little stuff here about everything that's available to you. All right. So notice the app theme, so I can change that if I want to. I don't want to. All right, that's just a couple of the things that you can work on in here. To check the layout, as I mentioned, I showed you zoom in and zoom out. I showed you how you can use different screen sizes. I clicked the go to next state button to go to landscape. All right. When I clicked the drop down, it only displayed the platform installed on the system, which was the 25. And I showed you how if you wanted to, you could change the theme. All right. On page 101, they show here, this unfortunately is going to be where you get different errors. Now, what I wanted to try to show you in here was if we go back to our code and I go back to the actual Java file that's in here, Okay, remember one of the things that we did a long time ago was we checked, it's in here somewhere, I know it is. We said here, if the amount, the build string amount is equal to nothing, set it equal to this. But notice what happens if I come in here. I'm going to purposely introduce an error into the program. So I'm going to say that the bill amount is equal to float parse bill amount dot string. Now you might think that's not an error. Well, watch. So I'm going to come in here and I'm going to do a save all and come back and run the program again. Choose my device, which is my only device that we have right now, and it's going to bring it up on the screen. Now, the reason I'm showing you this is previously, if we left nothing in there, it would have set our bill amount to 0. But since we've removed that, I want you to see what happens when I put nothing in the bill amount. All right, tip calculator has stopped. Open app again. It's not what I was looking for. Let's close the project and then let's open it again. All right, let's try to run it again. I don't know if that'll fix it or not. I don't want to have to reboot the system here. But what I want to show you here is I want to run this app and not put any output in there whatsoever. Since, if I try to do that, since I remove the lines here that checks for non-input, it's going to attempt to run a float.parts float on something right there that is just blank. That should, repeat, should give me an error where what should, repeat, should happen is something like this. Then it tells me, unfortunately, the tip calculator has stopped. All right, this isn't being very responsive right now. I'll give it just a second to see if it clears up, and if it doesn't, at least I've attempted to explain to you what would, could, should happen in here. This really shouldn't be taking, I wouldn't think, that much time. So let me jump back. Let's try this. Let's totally close this. Let's close this. It should at least close. There it goes. All right, let me bring up Android Studio again. I think at least this is an important enough concept to spend a couple minutes on with you. So again, as I mentioned, I came in here and where we had been, this was our error checking that said if there's nothing in that text box or edit text, that if there's nothing at all in there, that what we want to do is set it to 0. I'm removing that, so it's going to take whatever we put in there, including nothing, and set it to 0. So that is wrong. Hopefully that'll come up and run now. And again, if it doesn't, at least I tried to explain to you what the problem is. I'm trying to get the program to end. All right, and for lack of better words, to crash. Now, it might be, it's saying tip calculator stop, open app again. I don't think that what I did was enough to make it stop, but this is the kind of thing that you'll get. All right, so hopefully I didn't goop it up by doing that, but let's do this, and this, and that, and that, and that, and that. Now, hopefully that fixed it. So if I do a file save all and I run this again, and I click OK, now if it comes back and it stops again, well then I host something else up. So if this comes up with an error, something else is wrong with it. But like I said, at least, even though this took longer than I was hoping it would, at least I explained to you what's going on. Well, it's back. All right. So again, Now, if I leave it blank like this, it's going to automatically set that to 0. So notice, okay, basically it's 0. It already has been reset. So it's not giving me a keyboard right now, which I don't understand either. All right, but it is working. All right. So I want to go back to my slides. Now, when the system crashes, what you'll get is on the bottom of your screen, and this is always going to be the case, even if it doesn't crash, is you're going to see down here, and I might have to click View. There is an extra thing that's down here as an event log, not event log, but I want log cat. This is giving me an example of everything that's run down here. So run, monitor, there it is. So this is log cat in here. I don't actually need this one, this event log. All right, so here's my log cat. So when you start having errors in here, when you attempt to run the program, they will appear in here. So what the author is saying, that at least at times when you're checking your program, you're going to be able to go and look in there and probably be able to figure out what the problem is. So in this case, after a crash, there is some kind of an error in here, and it's telling you pretty much where the error is. It's not going to fix it for you, but it'll help you debug by telling you where the error is. All right, so there's the logcat window. All right. All right, it has different methods that you can use in it. These methods are shown in your textbook on the middle of page 103. Now, a couple things about using these methods. So one way to trace code execution is to use logcat logging. When you use logcat for debugging, you typically use the D method, the first one that's shown here, and that sends a debug message to the log. Each type of these messages that are here will display stuff in different colors. All right, you'll notice that each time the first parameter that's set there is tag, and that's used to identify the message in the logcat window. Typically what you'll do is you'll define a constant named tag in uppercase for each activity. All right, so they do show you examples here, and again, notice the colors. Blue for debug messages, red for error, orange for warning, and green for informational. That pretty much goes with Bootstrap and other types of colors, types of things. Now, when you're going to use this, you want to make sure to import android.util.log. And what we're doing here is we're setting up that tag parameter right there. So what are we doing here? Well, you'll notice these are just log statements with D for their debug. So it's going to tell us that we literally got into the calculate and display method. You can put anything you want in here, and this will allow us to print out the value that's in the bill amount. So it provides a fairly simplistic way to trace the execution of an app. All right, and again, the messages will be shown in the logcat window. All right, well, maybe you want more than that. So on pages 104 and 105, the author mentions in there that what you can also do is you can use what are called toasts, like you'd make toast. Kind of a weird name to give something, to call it toasts, but it's the one that they use. It's another way to trace execution. A toast is a message that briefly displays on the bottom of the screen. So for instance, if you had a program that was going to allow you to remove files, and you attempted to remove a file and it was successful, you might put a toast down here that came up and said file xyz.html deleted or something like that. What we could put in there is, if we were doing some debugging, this is kind of a silly toast message that they put in, but we could put in a toast message where, for example, we could even print out all of these amounts. So we could have put a toast in here that said bill amount 3460, percent 15, tip 519, total 2941 or something like that. This actually looks wrong. The bill amount was 3460. This number and this number should be transposed. I don't know why they've got it wrong like that, but they do. So if you want to use this, the first step is to import the toast class. All right. To do that, you basically add it from the, you import android.widget.toast with a capital T. The second step is to create a toast object. All right, so you say something and they don't show it here, unfortunately. There it is. There's the import. There's creating the toast object. Again, you can put whatever you want in here, and then you tell it to show. When you tell it to show, you can tell it to show either short or long. Short literally will show for about a second or so, where long shows for a few seconds. Now, that won't happen until you actually, call the .show method rather. And this is an example of what's called method chaining. We've got toast.makeText.show. So we're doing basically two operations in one. And we're telling it to run the first operation, the make text. When you get done with that, run the show operation. So you could use a toast for just about anything you'd like, but what's most common is to use it with debugging. Speaking of debugging, just like we saw, for example, in Visual Studio, I can come into here and I can click right here, okay? And you may or may not notice that little thing there. I've just set a breakpoint. If I click again, it's gone. All right? So you can do whatever you want or need to do with breakpoints because Android provides the debugger that you can use to debug the app without having to add or remove statements. Now, the author says on page 106 that this is a complex tool. It is, yet it's not. And what I mean by that is it's complex to use all the things that are available with it, but actually setting a breakpoint is not complex. So the first step is to find the cause of the bug. The easiest way to do that is while the app is running to set a breakpoint. I just showed you how to do that. It's important to set the breakpoint before the line in the app that's causing the bug. So if I knew the bug was being caused right here, for example, on this line, I'd want to set it before that because if I set it here, the code's already run. All right. Now, after you set one or more breakpoints, you need to run the app with the debugger. To do that, you can use the debug button that's in the toolbar, and that's right to the right. Debug app. All right, I believe that's the one there. Let's see. It's still running, and I believe that's the reason I'm getting a problem here. I think it's debug app right there. When you run the app with the debugger, Android Studio displays the debug window. And if for some reason it doesn't show it, although it should, you can always click the debug tab at the bottom of the main window. After you run an app with a debugger, the breakpoints remain where you set them until you click off, all right, to unset them. So a breakpoint is indicated by that little circle icon. They say it's red, it's more orange, I think. I showed you how to set it. When the app arrives at the breakpoint, the icon will change to an orange circle with a check mark. Once you set the breakpoint, all right, you run the program to begin debugging. Next, as we're perusing our way through the chapter. So that's the debug window. And when you come in here, all right, there's different things that you can look at and set. So when you run an app with a debugger and it encounters a breakpoint, the program execution stops before the statement at the breakpoint. And Android displays the debug window, which contains several other windows like the variables window and the frames window. All right, there's the frames, there's the variable window. At the top, the debug window displays some toolbar buttons, so there's ways that you can step through and step over your code. An advantage of doing this is if you use these buttons, you can step through your code a line at a time and watch what happens down in the variables window as you're stepping through. All right, so when you set breakpoints and step through code, the variables window automatically displays the variables that are in scope. In other words, anything that the system recognizes. And sometimes you'll see just the word this there. So you'll have to click right here and it'll show you the stuff that's inside. You can click in here too. A lot of times with some of the stuff that you click, you're going to look at it and go, this is just some really big number or a bunch of things with 0x and A's and B's. They're giving you addresses. All right. Within the debug window, the frames window has this in here has what's called the stack trace. And that's a list of methods that have been called in the program, but they're listed in reverse chronological order. In other words, the newest one is listed first. All right. All right. That's pretty much what we just stepped through right there. So the last part of the chapter, and I've already done this with you once, which is fine, I'll do it again, is how to create an emulator. So you have to be in Android Studio. In the toolbar, you click the button for the AWD manager, which should start the Android Virtual Device Manager and show all the emulators. All right. You click the Create Virtual Device button. You select the category. You select one of the available profiles. You select the available system images, and you enter a name for the emulator. It's even pretty much easier than that. All right. We've got our emulator right here. But remember, when we did this and we clicked here, all right, this shows us all of our emulators, but I could have created a new virtual device. So now I've only got the Nexus 1, but if I want to create a tablet emulator, I could put a Nexus 10 in here, for example. And if I'm cool with saving all of the debug or the default options, I can just click next. And yeah, I want 25 because that's the latest and greatest. I click next again. And it says, how do I want my orientation to be? Let's just keep it at portrait. And I'm going to click finish. All right, and I might have to click finish again, but I don't think so. So now I've got this. So I've got two different emulators. So now with this one chosen, if I click OK, what's going to happen is it's going to end up running the app, but it's going to end up running the app in the other emulator. So let's stop the run here. And then let's start it again. And we'll tell it to use our new Nexus 10. You notice they're both shown there. I'm going to click OK, and this should start it up. So I've just shown you how to create an emulator for a tablet. All right. In the appendix on page 610 through 617, they show you how to create an emulator for a Nexus S phone that's running Android 4.1. Well, again, it says installation failed. Possible existing version. Okay, let's try it. Now, to my knowledge, what I just showed you was sufficient. It may be, as they show, starting on page 610, that you've got to go back and run through it. And there may be more to it, because I'm getting an error installing APKs. I don't know what the problem is. There's my tablet, though. It may not look different, but it's running now. My program is running on a tablet instead of running on a phone. All right. So again, the how to create an emulator for a tablet, the steps I just ran through with you, but they're shown on pages 110 and 111. All right. And the last thing that's mentioned here in the chapter is how to create a new device definition. And the author mentions here, if the device definitions aren't adequate for you, you can click New Hardware Profile to create your own hardware profile. I think this is in my opinion, this is a little bit more advanced topic. Nothing wrong with talking about it, but I don't think it's something that as a beginning Android developer you're going to have to worry about, you're going to have to set. But if the Android version you want isn't available, you can download a system image for the Android version you want. When you do that, you can select an image that runs efficiently on your central processing unit. If performance is your main consideration, you can select a hardware profile that has a low density, such as HDPI or MDPI. In addition, you can select a system image for a lower image for an older version of Android if you want to check something that runs, on an older machine or see how it would look or whatever. They run through how to do this. I'm not going to do any more about it. So, as mentioned on page 114 as we finish this chapter, as your app grows more complex, you may need testing and debugging skills that are even go beyond this chapter, but this should get you started. It's important to realize that before you release an app, it should be thoroughly tested and debugged. Now that ends chapter 4, and it ends part 1 of our text, which started us all the way back on page 2, Getting Started Fast with Android, and it contained chapter 1, which was our introduction to Android Studio, chapter 2, which was how to start our first app, chapter 3, which was how to finish our app, and chapter 4, which we just went over on how to test and debug an Android app. Next, we'll start on section 2, which are essential Android skills, and we're going to go into chapter 5, where we'll learn more about getting input from the user and displaying output. I'll be back with that particular chapter in just a couple minutes.